here are a couple of the homework problems from the expected value section, section 12.4, that I'll go through here. I'm not sure what number these are. I think this might be number 2. It says, for an outdoor concert by the city orchestra, concert organizers estimate that 14,000 people will attend if it's not raining, and if it is raining, they estimate that 6,000 people will attend. And on the day of the concert, meteorologists predict an 80% chance of rain. So determine the expected number of people who will attend this concert. Okay, so obviously it makes sense that if it rains, less people are going to show. And if it doesn't rain, there's going to be more people. Okay, so what you've got here is you've got 14,000 people going to attend if it doesn't rain, and 6,000 will attend if it is raining. And on the day of the concert, it's predicted there's an 80% chance of rain. So this was one of the very first things we did with probability, the probability of not an event. So if the probability of an event is 80%, the probability of not the event is going to be 1 minus that, right? Because they have to add up to 100%. So the probability of no rain is then going to be 20%. So all this comes down to is expected value formula with 2 events, right? Remember expected value formula from the handout? It's just P1, A1 plus P2 times A2. And again, there's only 2 events here because it's either going to rain or it's not going to rain, right? So I guess we'll use P1 as not raining and P2 as raining. So what happens here is P1 times A1 are going to be the ones that are highlighted in yellow, right? P1 is the probability of no rain, which is 20%, and I would just write that as 0.2 times the amount of people that are going to attend if it doesn't rain, which is 14,000, and I'm going to add that to P2 times A2, and P2 is going to be the probability that it does rain, which is going to be 80%, which is 0.8, times the amount of people that will show if it does rain, which is only 6,000. Right? So now you just do this calculation. Right? 14,000 times 0.2 is going to be 2,800. And 6,000 times 0.8 is going to be 4,800. So when I add these 2 numbers together, I get 7,600. So the expected number of people who will attend is 7,600. So again, you can see how expected value doesn't always have to deal with money, right? In this case, it deals with expected number of attendees at a concert, right? So here they would expect 7,600. And it makes sense that that should be more towards the low side than the high side, because there's a much greater chance that it is going to rain than it isn't going to rain, right? So it comes out to only 7,600. So that's one. And then another one, which is a few problems later in the homework. Again, I'm not sure which number it is. It's another one of these raffle tickets ones. Okay, so now in this case, though, it's a little bit different than the one that came up in the handout, because in the one in the handout, there was only 1 prize. But in this case, there's actually 3 prizes. There's a $1,000, like, I guess, grand prize, if you want to call it that. And then there's 2 first prizes, or what you want to call that, which are $500 each. So in this case, you actually really have 3 events. You have the event that they win the $1,000, the big prize, the event that they win the $500, which is like the first prize, whatever you want to call it, and then there's the probability that they lose, right? So in this case, there's actually 3 events. So when I do the expected value here, I'm actually going to have P1A1 plus P2 A2 plus P3 A3, right? I have to cover all possible events. So this is like, this would be the event they win the 1,000. Let's say this is the event where they win the 500, and then we'll call this the event where they, oops, not win, where they will lose. Alright, so the probability that they win the 1,000 is only going to be 1 out of 2,000, and the probability that they win 500 is going to be 2 out of 2,000, which means that the probability that they lose, which we're going to call P3, right? There's only 3 winning tickets, so that means that there's 1,997 out of 2,000 losing tickets, right? So there's a lot of losing tickets in there. And the other key again here, which I didn't mention at the beginning and I should have, is that the tickets are sold for $3 each. So since the tickets are sold for $3 each, that really makes winning the grand prize not really winning $1,000, but only winning $997, and winning the second prize, right, which is $500, really only winning $497, because again, it's really 1,000 minus 3, and this is really 500 minus 3. And then of course A3, if they lose, that's going to be -3, which is the price that they sold, that they bought the ticket for, right? And she's only purchasing one of these tickets, okay? So that's why A3 is -3. So now again, it's just filling in numbers, right? I have all these numbers listed, right, don't I? Well, P1 I don't have listed, I have it highlighted. The probability that they win the 1,000 is 1 out of 2,000. And if they win the grand prize, what really happens, let's fix this a little bit. If they win the grand prize, they're really winning $997. And their probability of winning the second prize is 2 out of 2,000. And if they win the second prize, they win $497. And then their probability of losing is by far the greatest probability, which is 1997 out of 2,000. And if they lose, they just lose the $3. Okay? So these calculations aren't as bad as they seem because they all have denominators of 2,000, right? So this is 997 out of 2,000 plus 994 out of 2,000 minus 5,991 out of 2,000. So when I add up those numerators, right, let's do this on a calculator so we don't mess it up. It would be 997 plus 994 minus 5991, which is -4,000. So -4,000 over 2,000. So that means their expected value is actually -2. Right? -4,000 over -2,000 over -4,000 over 2,000 is just like -4 over 2, which is -2. Alright, so expected value here is -2. And then of course the fair price then, once I have the expected value, the fair price is easy. I just use my fair price formula, which is the expected value plus the cost to play and the expected value was -2, the cost to play was $3. So the fair price is actually going to be $1. So the expected value is $2, and then the expected value is -$2, and then the fair price is $1. And again, you can see that this fair price makes sense, because remember what we said the fair price is. The fair price is the amount that they would charge if they're just going to break even. So if there were 2,000 tickets, here, this is like a separate, this is kind of almost like a check really more than anything else. So I'll keep this separate here. If there's 2,000 tickets and they cost $1 each, that means they're taking in $2,000 in revenue. When I say they, I mean like the people who are running this raffle, like the house, right? At a casino, it would be called the house. So there's 2,000 tickets, and you sell them for $1 each, so you're taking in $2,000 in revenue, but then you're giving out a $1,000 prize, and two $500 prizes. So you're giving out $2,000 in prizes. So you're taking in the same amount that you're giving back in prizes. So that's why the fair price is $1, right? Because in that case, they wouldn't be making money, they wouldn't be losing money, they'd just be breaking even. So you can pretty much always do it. I mean, not always, but most of the time you can do a check like that after you find the fair price and make sure that it does actually work out where the house will be breaking even. Okay, so I mean, those are basically the kind of problems that you're going to see with expected value.